विद्यार्थी मित्र, यापूर्वीच आपण कंटिन्युटी जे काही एक्सरसाइज होते ते पूर्णपणे केले. यानंतर आपण कंटिन्युटी मिसलेनियस एक्सरसाइज बघणार आहोत. नाउ लेट अस स्टार्ट. Miscellaneous exercise set. Select the correct answer from the given alternatives. F of x is equals to 2 raised to cot x minus 1 upon pi minus 2x for x is not equals to pi by 2. And f of pi by 2 is equals to log of root x. That is at the x is equals to pi by 2. Next. Solve this example. That is f of pi by 2 is equals to log of root 2. Limit x tends to pi by 2, f of x is equals to limit x tends to pi by 2. 2 raised to cot x minus 1 upon pi minus 2x. Now to solve this type of the examples, we take the substitutions. Substitutions आपण घेत असतो यामध्ये x is equals to pi by 2 plus h. As x tends to pi by 2, then h tends to 0. म्हणजे इथे जर आपण x च्या जागी pi by 2 टाकला, pi by 2 on both sides get cancelled, then you will get h is equals to 0. And that's why we say that it is h tends to 0. Therefore, our limit becomes limit h tends to 0, 2 raised to cot of pi by 2 plus h minus 1 upon pi in bracket pi minus 2 in bracket pi by 2 plus h. Now in this case, cot of pi by 2 plus h means it goes in second quadrant. In second quadrant, cot is negative, and that's why it is a minus tan h. Whenever there is angle pi by 2 plus theta, the function changes. Tan to cot, cot to tan, and in this case here, it becomes minus tan of h minus 1, and their simplification now, then you will get limit h tends to 0, 2 raised to minus tan of h minus 1. Now in this case, this is of the form that is limit a raised to x minus 1 upon x. Now in this case, 2 raised to minus tan h minus 1 upon minus tan h must be 0. But actually there is not minus tan h. Therefore here we adjust minus tan of h to the numerator and the denominator. And then what's happening? The happening is that minus tan of h upon minus 2h, and we can solve this limit easily. That is equals to h to 1 upon 2. Now see this here. That is 1 upon 2 is here. 1 upon 2. Tan of h upon h. The value of this limit is 1. And 2 raised to minus tan h minus 1 upon minus tan h. And overall the value of this limit is log of 2 into 1 into 1 upon 2. And hence the answer is 1 upon 2 log of 2. That is by using the properties of the logarithm. That is, what is that property? Log of m raised to n is equals to n into log of m. And in this case, here is 1 upon 2 log of 2. Means what? Log of 2 raised to 1 upon 2. Then you will get a log of root 2. Therefore, limit x tends to pi by 2, f of x is equals to f of pi by 2 log of root 2. Therefore, from 1 and 2, the given function is continuous at x is equals to pi by 2, and hence option that is A is continuous at x is equals to pi by 2. Now second, if f of x is equals to 1 minus root 2 sin x upon pi minus 4x, for x is not equals to pi by 4, is continuous at x is equals to pi by 4, then find f of 4. So in this case, f of x is equals to 1 minus root 2 sin x upon pi minus 4x, for x is not equals to pi by 4. This function is continuous at x is equals to pi by 4. Then what is the value of f of pi by 4? As given function is a continuous, the value of the function is equals to the limit of the function, and by using this we can solve it. As a given function is continuous at x is equals to pi by 4, f of pi by 4 is equals to limit x tends to pi by 4 f of x. Limit x tends to pi by 4, 1 minus root 2 sin x upon pi minus 4x. Put x is equals to pi by 4 plus h, as x tends to pi by 4, h tends to 0. Now in this case, limit x tends to 0, 1 minus root 2 sin of pi by 4 plus h upon pi minus 4 in bracket, that is x is replaced by pi by 4 plus h. Therefore, you will get limit h tends to 0, 1 minus root 2 sin of pi by 4 plus h. Expand this by using the formula sin of a plus b. What is the sin of a plus b? Sin a sin b plus cos a sin b. By using this formula, here is the sin of pi by 4 cos h plus cos of pi by 4 and sin h upon. Now simplification of this, 4 is multiplied with pi by 4 plus h. Now in this case, this 4 get cancelled. Then you will get minus pi and minus 4h. That is plus pi minus pi get cancelled. And you will get minus 4h. Therefore, limit h tends to 0. And substitute the value of sin of pi by 4 is 1 upon root 2. Cos of pi by 4 is 1 by root 2. Take 1 by root 2 as a common. Then in bracket you will get cos of h plus sin h. Root 2 get cancelled. And this is very interesting limit. Limit h tends to 0. Now see this here. That is a root 2 get cancelled. Then you will get 1 minus cos h in first bracket. What about the second bracket? Here is again minus sin of h upon h. Split up this. That is a 1 minus cos of h upon minus 4h minus sin of h upon 4h. And now to solve, evaluate this limit. Limit h tends to 0. 1 minus cos h upon minus 4h into multiplied n and d by 1 plus cos h. I always solve this type of examples by using the rationalization of this. I can also solve this example by using the formula. What is that formula? 1 minus cos of a is equals to 2 sin square a by 2. But I think that whenever there is an angle, this angle is even, then there is no problem. Means what? What do you mean by even? 1 minus cos of 2x. Then what is the formula? 2 sin square 2x upon 2. That 2 get cancelled, we can't get the fraction. But in this case, we will get the fraction, and most students cannot solve it properly. Sometimes by mistake, the answer is not the correct. Therefore, I rationalize this numerator and get the answer. For the second, sin of h upon h 1 by 4. Now 1 minus cos square h upon minus 4. 1 by 4 sin of h. Limit h tends to 0. Now here is sin square h upon h square. I adjusted here h. Therefore, value of this limit will be the 1. But what about here? That is h tends to 0. This limit becomes 0. This total will become 0. 1 by 4. Sin of h upon h is 1. And overall, we will get 1 by 4. Therefore, L is equals to 1 by 4. And hence option D is the correct one. Now the third one, if f of x is equals to sine of 2x into tan of 5x upon e raised to 2x minus 1 bracket square for x is not equals to 0. लिमिटसाठी ऑब्झर्वेशन सगळ्यात जास्त इम्पॉर्टंट असतं to solve this type of the limit. Okay, now here is a sin x, it required x, tan of 5x, it required again x. And what about the denominator? E raised to 2x minus 1 bracket square, it will require x square. What is our standard formula? E raised to x minus 1 upon x. Therefore divide n and d by x square, then we can get the solution of this problem. Continuous at x is equals to 0, then find f of 0. The given function is continuous, and that's why the value of the function is equals to the limit of the function. And therefore, as the given function is a continuous, given function is a continuous, f of 0 is equals to limit x tends to 0, f of x sine of 2x into tan of 5x minus e raised to 2x minus 1 bracket square. Now divide n and d by x square, limit x tends to 0, sine 2x upon x into sine of divided by 5. Adjust 5, that is a 2 into 5. That is the limit sine of 2x upon 2x into 2, tan of 5x upon 5x into 5. The value of this limit is 1 into 2, 1 into 5. And the value of this limit is a 1 square into 4. Now, see this here. That is equals to 5 by 2. Now, we'll see all the examples. Now, see this, all the examples. That is f of x is equals to 2 raised to cot x minus 1 upon pi minus 2x. F of x is equals f of pi by 2 is equals to log of root 2. Here we have the value of f of pi by 2 is equals to log of root 2. Limit x tends to pi by 2. F of x is equals to limit x tends to pi by 2. 2 raised to cot x minus 1 upon pi minus 2x. Again, I am summarizing all these problems. That you put x is equals to pi by 2 plus h, as x tends to pi by 2, h tends to 0. Then you will get limit L is equals to h tends to 0, 2 raised to cot of pi by 2 plus h minus 1 upon pi minus 2 in bracket pi by 2 plus h. Then you will get, that is the limit L is equals to h tends to 0, 2 raised to minus tan h minus 1 upon plus pi minus pi get cancelled, minus 2h. Then this is the limit of the form, that is the a raised to x minus 1 upon x, that is a 2 raised to minus tan h minus 1 upon tan of h into tan of h upon h into 1 upon 2. And therefore, the limit of this 2 raised to minus tan h upon tan h minus 1 upon tan of h is a log of 2. As h tends to 0, tan of h also tends to 0. I am not writing here. Therefore, the answer is log of 2. Limit is this 1 upon 2. And overall, you will get 1 upon 2, a log of 2, a log of root 2 by using the property of logarithm. Here is a 1 upon 2. Therefore, it's a 2 raised to 1 upon 2. That is a log of root 2. And hence, limit x tends to pi by 2. F of x is equals to f of pi by 2 is equals to log of root 2. And therefore, as given function is a continuous at x is equals to pi by 2, and therefore f is a continuous at x is equals to pi by 2. This is the first. Now, the second one, that is a 2. If f of x is equals to 1 minus root 2 sin x upon pi minus 4x, for x is not equals to pi by 4, is continuous. At x is equals to pi by 4, then find f of pi by 4. Again, given function is a continuous, and that's why limit of the function is equals to the value of the function. Now, again, f of pi by 4 is equals to limit x tends to pi by 4 f of x. limit x tends to pi by 4, 1 minus root 2 sin x upon pi minus 4x. Now put substitution is here. इथे substitution आपण करत असतो. X is equals to pi by 4 plus h, as x tends to pi by 4, h tends to 0. Now again, limit h tends to 0, 1 minus root 2 sin of pi by 4 plus h upon pi minus, in bracket, 4 into pi by 4 plus h, and their substitutions. After the substitutions, you will get sin of a plus b, that is a sin a cos b plus cos a sin b. Using that formula, sin of pi by 4 is 1 by root 2, means what? Cos of h upon root 2 plus sin of h upon root 2. Take root 2 as a common, then root 2 to get cancelled, upon minus 4h. Therefore, we'll split up here 1 minus cos of h upon minus 4h minus sin of h upon minus 4h. This minus will become plus, and that's why you will get the next is. Now again, to solve this type of the limit 1 minus cos of h upon h. To solve this limit, I will rationalize this. That is 1 minus cos of h into 1 plus cos h. Numerator denominator multiplication. That is, you will get 1 minus cos square h upon h. That is, will become sin square h upon h square. I am adjusting here h. That is multiplied and by h. Then you will get h square, and here is a one more extra h. Now if you take the limit of this, sin square h upon h square is a 1 into, but here is a h, and overall this limit will become 0. That is minus 1 by 4, this is a 1 square and this is a 0. 1 plus cos h, as h tends to 0, cos of 0 is 1, that is overall this will become 0. But what about here? Sin of h upon h is 1, and which is 1 by 4, and hence the overall the limit is 1 by 4, and hence option D is the correct one. Now the next is, if f of x is equals to, now in the question number 3, if f of x is equals to sin of 2x into tan of 2x, tan of 5x upon e raised to 2x minus 1 bracket square for x is not equals to 0, is continuous at x is equals to 0, then find f of 0. Then the options are A, B, C, D. Now my job is that to find out the limit of the given function. That is, f of 0 is equals to limit x tends to 0, f of x. Limit x tends to 0, sin of 2x into tan of 5x upon e raised to x minus 1 bracket square. Now if we see this, that is a limit x tends to 0, sin 2x into tan of 5x upon e raised to 2x minus 1 bracket square. Now in this case, divide n and d by x square, then one x will be here, another x here, and upon x square. Now see this here. Divide n and d by x square, then limit x tends to 0, sin of 2x upon x into tan of 5x upon x. Now in this case, e raised to 2x minus 1 bracket square upon x square. Now here we will adjust 2 here for the sin of 2x upon 2x into 2. Tan of 5x upon 5x into 5. And what about here? E raised to 2x minus 1. But we have x square. There must be the 4x square. Therefore, e raised to 2x minus 1 upon 2x bracket square into 4. That is, the 4 is adjusted here. Therefore, the limit of this function is sin of 2x upon 2x is 1. 1 into 2. 1 into 5. And overall, this is the limit of this function is 1 square. 1 into 4. And overall, you will get the 4 here. That is 2 into 5, 10. 10 by 4. That is equals to 5 by 2. And hence, the option D is the correct one. Now the fourth option, if f of x is equals to x square minus 7x plus 10 upon x square plus 2x minus 8 for x belongs to closed interval minus 6, 3. Now see this here. This is the polynomial function. That is a rational p of x upon q of x. We will factorize it. X minus 5. Their factorization is x minus 5 into x minus 2 upon x plus 4 into x minus 2. X minus 2, x minus 2 get cancelled. And then you will get f of x is equals to x minus 5 upon x plus 4. At x is equals to minus 4, given function is discontinuous. At x is equals to minus 4. Therefore, f is discontinuous at x is equals to minus 4, otherwise it is a continuous. Now see this again. Now see this here, again here, f of x is equals to x square minus 7x plus 10 upon x square plus 2x minus 8 for x belongs to closed interval minus 6 to 3. Now f of x is equals to, factorize it. Simple factors, x minus 5 into x minus 2, x plus 4 into x minus 2, x minus 2 get cancelled. Therefore f of x is equals to x minus 5 upon x plus 4 for x belongs to the closed interval minus 6 to 3. At x is equals to minus 4, the denominator will become 0 and hence the given function is a discontinuous at x is equals to minus 4, and therefore f is a discontinuous at x is equals to minus 4. Now we'll see the next example. F of x is equals to ax square plus bx plus 1 for mod of x minus 1 is greater than or equal to 3. 4x plus 5. F of x is equals to 4x plus 5 for x lies between minus 2 to 4 is a continuous everywhere. Then f of x is equals to ax square plus bx plus c. See this here, we want to find out the values of a, b, c. F of x is equals to x square plus bx plus c for mod of x minus 1 is a greater than or equal to 3. Now this is very important, interesting. Now here is a mod of x minus 1 which is greater than or equal to. If we withdraw the mod sign, then you will get plus or minus of this quantity, these two quantities. Therefore, that is a minus 3 less than or equal to x minus 1 is a less than or equal to 3. If you add 1 in these inequalities, then you will get minus 3 plus 1, x minus 1 and plus 1 and 3 plus 1. Then you will get that is a minus 2, x and 4. That is x lies between 2 we'll check the continuity at x is equals to 2. It's a left, right. Now I will repeat here. That is f of x is equals to x square plus bx plus c for mod of x minus 1 greater than or equal to 3. Therefore x minus 1 is greater than or equal to, this is first one. When it is a negative, that is a minus in bracket x minus 1 greater than or equal to 3. Add 1 on both sides, that for x is a greater than or equal to 3 plus 1. Or if we evaluate this, then you will get minus x plus 1 greater than or equal to 3. Therefore you will get x is greater than or equal to 4. Or 1 minus x, that is add x on both sides and minus 3 on both sides, then you will get 1 minus 3 greater than or equal to x. Therefore here x is greater than or equal to 4 or minus 2 is greater than or equal to x. It means that x is x is less than or equal to minus 2. Therefore we have the two things, that is x is greater than or equal to 4 or x is less than or equal to minus 2. Then what type of the function will be? For this type of function f of x square plus bx plus c, if we evaluate this, then we get the two types of the values of x. One is x is greater than or equal to 4 when this function exists, and another is x is less than or equal to minus 2. Therefore f of x is equals to x square plus bx plus 1 for x is less than or equal to minus 2. And what about the next? Next is as it is, we have taken it is as it is, which is that is a 4x plus 5, where x lies between -2 to 4. Therefore, I had kept it as it is, -2 to 4. First is x is less than or equal to -2. What will the next? X is the greater than -2. And what about the next? Next will be the x is the greater than or equal to 4, which is nothing but this. Therefore, f of x is equals to x square plus bx plus 1 for x is less than or equal to -2, and this is as it is. And this is the, from this, that is the f of x is equals to x square plus bx plus 1 for x is greater than or equal to 4. Now we'll check the continuity at the 2 points. Which are the 2 points where the function breaks? The given function break at x is equals to -2 and x is equals to 4. Therefore, continuity at x is equals to 4. Limit, left hand side limit x tends to 2. Now here we will take the check the continuity at x is equals to 2. That is limit x tends to left hand side limit after the f of x, limit x tends to -2. The function is ax square plus bx plus 1. Replace x by -2, then you will get a into -2 bracket square plus b into -2 plus 1. And if you evaluate this, then you will get left hand side limit, that is a 4a minus 2b plus 1. This is the equation number 1. Now we will take the right hand side limit. For that, the function is 4x plus 5. How it is? This is the right hand side limit, because the value of the x is greater than -2. Therefore, this is the right hand side limit. And in this case, here we will take the limit and replace x by -2. That is a 4 into -2 plus 5. That you will get -8 plus 5. And overall, you will get the limit is -3 for the right hand side limit at x is equals to -2 for the right hand side limit. Now the given function is a continuous at x is equals to -2. Left hand side limit is equals to the right hand side limit. 4a minus 2b plus 1 is equals to -3. And if you evaluate this, then you will get 4a minus 2b is equals to -4. Evaluate this, divide this equation by 2, then you will get 2a minus b minus 2. Now check the continuity at x is equals to 4. Therefore, here again we will take the left hand side limit and the right hand side limit. If you see this function, that is here x is a less than 4, and for that you will take the left hand side limit for this function, and the x is a greater than or equal to 4, you will take the right hand side limit for this function. Therefore, here that is the limit continuity at x is equals to 4, limit x tends to 4, left hand side limit 4x plus 5, you replace x by 4, 4 into 4, that is a 16 plus 5, which is equals to 21. Now the right hand side limit x tends to 4, f of x is equals to limit x tends to 4, ax square plus bx plus 1, then a into 4 square plus b into 4 plus 1, 16a plus 4b plus 1, therefore 16a plus 4b plus 1 is equals to 21, 4a plus 4b is equals to 20, and if you evaluate this, that is the you will get, if you divide by 4, then you will get 4a plus b plus 5. Now by using that first equation, that is equation number 2 and the equation number this 5, we will evaluate this. If you add these two equations, then you will get 6a is equals to 3, therefore a is equals to 1 upon 2. Substitute the value of this a in 2a minus b is equals to -2, then you will get the value of b, that is equals to 3, and hence the a is equals to 1 upon 2 and b is equals to 3, then you will get a is equals to 1 upon 2 and b is equals to 3. This is the option A is the correct one. Question number 6. F of x is equals to 16 raised to x minus 1 into 9 raised to x minus 1 upon 27 raised to x minus 1, 32 raised to x minus 1 for x is not equals to 0, equals to k for x is equals to 0. is a continuous at x is equals to 0, then find the value of the k. These are the options. This is very simple. Given function is a continuous, the value of the function is equals to the limit of the function. Therefore, here we will solve the limit, that is limit x tends to 0. 16 raised to x into 9 raised to x minus 1 upon 27 raised to x minus 1 into 32 raised to x minus 1. Divide n and d by x square. Then you will get limit x tends to 0. 16 raised to x minus 1 upon x into 9 raised to x minus 1 upon x upon 27 raised to x minus 1 upon x into 32 raised to x minus 1 upon x. The value of this limit is a log of 16, log of 9, log of 27, log of 32. And this can be again, that is written as log of 16 means what? 2 raised to 4. This is the log of 3 raised to 2. Log of 27 means what? 3 raised to 3. Log of 32 means what? 2 raised to 5. And if we evaluate this, then you will get 4 log of 2, 2 log of 3, then 3 log of 3 into 5 log of 2, these get cancelled, you will get 8 upon 50. And hence, the option B is the correct one. Now see this again here. That is a 16 raised to x minus 1, 9 raised to x minus 1 upon 27 raised to x minus 1, 32 raised to x minus 1 is a continuous at x is equals to 0. Divide n and d by x square. The first is limit of this is log of 16, log of 9, log of 27, log of 32, and log of 16 can be written as 2 raised to 4, log of 3 raised to 2, log of 3 raised to 3, log of 2 raised to 5, and by using the properties of the log, that is a 4 log of 2 into 2 log of 3 upon 3 log of 3 into 5 log of 2, and you will get 8 upon 50, and hence option B is the correct one. Now the next is f of x is equals to 32 raised to x minus 8 raised to x minus 4 raised to x plus 1 upon 4 raised to x minus 2 raised to x plus 1 plus 1. For x is not equals to 0 and equals to k, for x is equals to 0. Is a continuous at x is equals to 0, then find the value of k. The values are 6, 4, log of 2 into log of 4, 3 log of 4. As given function is a continuous, k is equals to limit x tends to 0, 32 raised to x minus 8 raised to x minus 4 raised to x plus 1, 4 raised to x minus 2 into minus 2 raised to x plus 1 plus 1, and if we evaluate that, then you will get, what is the 32? 2 raised to 5 in bracket raised to x. 8 means what? 2 raised to 3 bracket raised to x. 4 means what? 2 raised to 2 bracket raised to x plus 1. And to the denominator, here is a 2 raised to 2 bracket raised to x minus 2 raised to x plus 1 means what? 2 into 2 raised to x. Therefore, you will get limit x tends to 0. Evaluate this. Then 2 raised to 5x, 2 raised to 3x, 2 raised to 2x plus 1, 2 raised to 2x minus 2 raised to 2 into 2 raised to x. It's a bracket square. If you take the 2 raised to 3x common from these two, then in bracket you will get 2 raised to 2x minus 1, and minus sign common from these two, then you will get 2 raised to 2x minus 1. Therefore, 2 raised to x minus 1 bracket square. Divide n and divide now x square. Then it will be like this. That is the limit x tends to 0, 2 raised to 2x minus 1. We have adjust here 2 raised to 2x minus 1 upon 2x into 2 into 2 raised to 3x minus 1 upon 3x into 3. It's a bracket square. This is the first bit, log of 2. Second is also log of 2 into 3, log of 2, bracket square. Again these get cancelled, then you will get 6. That is option A is the correct one. Now see this again here. That is f of x is equals to 32 raised to x minus 8 raised to x minus 4 raised to x plus 1 upon 4 raised to x minus 2 raised to x plus 1 for x is not equals to 0 equals to k. For x is equals to 0, given function is a continuous, find the value of k. Now see this k is equals to 32 raised to x, 8 raised to x, 4 raised to x plus 1, 4 raised to x minus 2 raised to x plus 1 plus 1. 32 means what? 2 raised to 5 bracket raised to x minus 2 raised to 3 bracket raised to x minus 2 raised to 2 bracket raised to x plus 1. 2 raised to 2 bracket raised to x minus 2 into 2 raised to x plus 1. That is a 2 raised to 5x minus 3 raised to 2 raised to 3x minus 2 raised to 2x plus 1. And to the denominator 2 raised to x minus 1 bracket square. Now we can take from the numerator first, from the first two terms, we can take the 2 raised to 2x, 3x common. And the remaining 2, we can take minus 1 common. Then you will get 2 raised to 2x minus 1. That is here 2 raised to 2x minus 1 in first bracket, in second bracket 2 raised to 3x minus 1. Divide n and divide x square. Then you will get 2 raised to 2x minus 1 upon x into 2 raised to 3x minus 1 upon x. And to the denominator 2 raised to x minus 1 bracket square upon x square. Now here the limit of this, we will adjust here 2. That is a 2 raised to 2x minus 1 upon 2x into 2. 2 raised to 3x minus 1 upon 3x into 3. And to the denominator 2 raised to x minus 1 upon x whole square. The value of this limit is log of 2, log of 2. That is a log of 2 square. And 2 into 3, that will become 6. Now see this here. This log of 2 and to the denominator, the limit will be the log of 2 bracket square. And overall you will get the 6, and hence option A is the correct one. Now see this again here. Next example. If f of x is equals to 12 raised to x minus 4 raised to x minus 3 raised to x plus 1 upon 1 minus cos of 2x for x is not equals to 0, is a continuous, at x is equals to 0, then the value of f of 0 is, again very interesting examples. Overall if you see this, the सर्व examples कडे बघितल्यानंतर आपल्याला असं समजतं की ते नंबर ऑफ द टाइम्स आपली लिमिट सॉल्व करण्याची प्रॅक्टिस करून घेतात. लिमिट x टेंड्स टू 0, f of x is equals to, which is the given function, that is a 12 raised to x minus 4 raised to x minus 3 raised to x and plus 1. Now here is a 12. 12 means what? 4 into 3. That is the limit x tends to 0 in bracket 4 into 3 bracket raised to x minus 4 raised to x minus 3 raised to x plus 1 upon 1. Now here is one thing is important, that is a 1 minus cos of 2x. Here we will apply the formula because we can't get the fraction here. Fraction means what? The angle of this here. That is 1 minus cos of a is equals to 2 sin square a upon 2. If here is a 1 minus cos s, then you will get 2 sin square x upon 2. That is a fraction. But here the angle is a 2x. Therefore, we apply the direct formula here. We are not rationalizing this 1 minus cos of 2x. That is a 2 sin square 2x upon 2. Here 2 get cancelled. You will get 2 sin square x. Very simple limit will be there. limit x tends to 0, 4 raised to x into 3 raised to x. That is a 2 sin square x. Limit x tends to 0, 4 raised to x in bracket 3 raised to x minus 1. Minus sign is common. 3 raised to x minus 1, 2 sin square x. Therefore, you will get 3 raised to x minus 1 into 4 raised to x minus 1 upon 2 sin square x. Now divide n and d by x square. That is a 1 upon 2. Limit x tends to 0, 3 raised to x minus 1 upon x, 4 raised to x minus 1 upon x, sin square x upon x square. That is the 1 upon 2 log of 3 into log of 4 upon 1. That is the 1 square. And overall, you will get, that is a log of 4 is nothing but the log of 2 bracket square into log of 3. That is a log of 2 into log of 3. And option B is the correct one. Now see this again here. That is a, if f of x is equals to 12 raised to x minus 4 raised to x minus 3 raised to x plus 1 upon 1 minus cos of 2x for x is not equals to 0 is a continuous at x is equals to 0, then the value of f of 0. Again, solve this limit. See this again. X tends to 0. 12 can be written as 4 into 3. Use the formula 4 raised to x, 3 raised to x. Take the common 4 raised to x from these two, minus 1 from the remaining 2. Apply the formula 3 raised to x minus 1 into 4 raised to x minus 1 upon 2 sin square x. Divide n and d by x square. That is a 1 upon 2. Limit x tends to 0. 3 raised to x minus 1 upon x into 4 raised to x minus 1 upon x. Again see this here. Divided by x square. And therefore you will get 1 upon 2 log of 3 into log of 4. And that's why 1 upon 2 log of 2 square log of 3. These two get cancelled. You will get log of 2 into log of 3. Option B is the correct one. Now the next is example number 9. If f of x is equals to 4 plus 5x upon 4 minus 7x, bracket is to 4 upon x for x is not equals to 0, and f of 0 is equals to k is a continuous at x is equals to 0, then k is, these are the values of the k. L is equals to limit x tends to 0, 4 plus 5x upon 4 minus 7x, bracket is to 4 upon x. Divide n and d by 4. Very interesting example. Divide n and d by x. That is, you will get 1 plus 5 upon 4x whole divided by 1 minus 7 upon 4x and bracket is to 4 upon x. Now split up this numerator and in the denominator form. That is limit x tends to 0, 1 plus 5 by 4x bracket is to 4 upon x and the whole divided by limit x tends to 0, 1 minus 7x upon 4 and whole bracket is to 4 upon x. Now see this here, 1 plus 5x upon 4. The reciprocal of this is 4 upon 5x. Limit x tends to 0, 1 minus 7 by 4x. And the value of this limit, that is 1 minus 7x upon 4, and we can write it's a reciprocal, that is a minus 4 upon 7x and whole bracket is to minus 7, that is e raised to 5 upon e raised to minus 7, and if we evaluate this then you will get e raised to 12. Therefore option C is the correct one. Now again see this here. Again divide n and d by 4. That is 1 plus 5x upon 4. Bracket is to 4 upon x. Limit 1 x tends to 0, 1 minus 7x upon 4. Bracket is to 4 upon x. Adjustment. What is here? That is 4 upon x is already there. we have adjusted only the 5, that is a 4 upon 5x. We adjust here 5, and to the next, for the denominator, what is here? 1 minus 7x upon 4, and bracket is to 4 upon x. That is the limit x tends to 0. 1 minus 7x upon 4 minus 4 upon 7x minus 7. Therefore, here you will get e raised to 5, and to the denominator e raised to minus 7. And overall, you will get e raised to 12. Therefore, the option C is the correct one. Now, the next is if f of x is equals to the greatest integer function, x belongs to minus 1 to f is a continuous at x is equals to, at which point the given function will be continuous. Here is the correct answer. X is equals to 0 and 1. The option C is the correct one. Now see this again. I will explain here. That is the f of x is equals to greatest integer functions. X belongs to minus 1 to open interval. F is a continuous. And in this case, the greatest integer function, that is, we take here is a 0 and the 1. This type of the problems we have also solved before that. Now we'll take the next question. Discuss the continuity of the following functions at the points or on the interval indicated against them. F of x is equals to x square minus 3x minus 10 upon x minus 5. For x lies between 3 to 6 and x is not equals to 5, equals to 10. For x is equals to 5, x square minus 3x minus 10 upon x minus 5. The value of x lies between 6 to 9. Now the given function can be expressed as f of x is equals to x square minus 3x minus 10 upon x minus 5 for the values of x. X is equals to 5. This is the rational function. And is continuous for the values of the x lies between 3 to 9 and x is not equals to 0. Here we'll check the continuity at x is equals to 5. The continuity at x is equals to 5. F of 5 is 10. That is given. I will take the limit. F of x, limit x tends to 5, x square minus 3x minus 10 upon x minus 5. X minus 5 get cancelled, and you will get that is equals to 7, which is not equals to f of 5. Therefore, f is a discontinuous at x is equals to 5. Therefore, f is a continuous everywhere except at x is equals to 5. where it's a denominator becomes 0. Now see this again here. Discuss the continuity of the function at the point or the interval indicated against them. This is the function exists here at x is equals to 5, and for the value of x we slice between 6 to 9. This is a polynomial rational function p of x upon q of x. This is also continuous and x is not equals to 5. It's clear that the given function is a continuous. Given function is a continuous except at x is equals to 5. Now we'll check it here. The given function, can be written as again. Therefore, continuity. We'll check the continuity at x is equals to 5. F of 5 is 10. We'll take the limit. That is the limit x tends to 5, x square minus 3x minus 10 upon x minus 5. Factorize it. Get the limit which is 7, which is not equals to f of 5. Hence the given function is a discontinuous at x is equals to 5. Therefore, f is a continuous everywhere in closed interval 3 to 9. We take here closed interval. What is the interval? That is a 3 to, no, this is 3 to 9. Therefore, the given function is a continuous except at x is equals to 5. Now the next problem. F of x is equals to 2x square minus 2x plus 5 for x lies between 0 to 2. 1 minus 3x minus x square upon 1 minus x for x lies between 2 to 4. And equals to x square minus 25 upon x minus 5 for x lies between 4 to 7. And equals to 7 for x is equals to 5. The domain of f is closed interval 0 to 7. For x lies between 0 to 2, f of x is equals to 2x square minus 2x plus 5. Being a polynomial function, is a continuous. And for the next 2 to 4, again being rational because it is of the form p of x upon q of x. Is a rational function. It is p of x upon q of x. Is a continuous except at x is equals to 1. And again 1 is not included there. Which is not belongs to that interval 2 to 4. For x lies between 4 to 7, x is not equals to 5. X square minus 25 upon x minus 5 being a rational function, it's a continuous again except at x is equals to 5. It's a denominator. At the point x is equals to 5. The continuity at x is equals to 5. F of 5 is at 7, which is given, and solve this limit. That is split a bit. Therefore, you will get 10. The given function is a discontinuous at that point. Therefore, limit is not equals to the value of the function. Therefore, it is this is not continuous at x is equals to 5. Hence, f is a continuous on its domain except 0 to 7 except at x is equals to 5, where it is a discontinuous. Now see this again here. F of x is equals to 2x square minus 2x plus 5, x lies between 0 to 2, 1 minus 3x minus x square upon 1 minus x for x lies between 2 to 4, x square minus 25 upon x minus 5, 4 to 7, x is not equals to 5 and equals to 7 for x is equals to 5. The domain of f is the domain. This is a 2 to 7 directly. Therefore, domain of this is, and it is a split up in this manner: 0 to 2, 2 to 4, 4 to 7. For 0 to 2 being a polynomial function, this is a polynomial function, it is a continuous, no problem. And 2 to 4, this is a 2 to 4. Again it is a continuous. Again it is a rational type of the function, p of x upon p of x. Now see this here, 2 to 4 being a function of the form p of x upon p of x is a continuous except at x is equals to 1. But it is not included here. Therefore p of x upon p of x is a continuous in that interval 2 to 4. And what about the last? The last is here, that is x square minus 25 upon x minus 5. And in this case, that is a continuity at x is equals to 5. F of 5 is 7. Therefore, limit x tends to 5 f of x. X square minus 25 upon x minus 5. Split up it. Cancel it. The value of that is equals to, because we have the at x is equals to 5. What is the value? Value is 7. Take the limit here. And if you evaluate that, then you will get the limit is 10. The value of the function is not equals to the limit. Therefore, the given function is a not continuous at x is equals to 5. And hence, f is a continuous on its domain 0 to 7 except at the point x is equals to 5, where it is a discontinuous. Now the next is f of x is equals to cos of 4x minus cos of 9x upon 1 minus cos x for x is not equals to 0. F of 0 is a 68 upon 15 at x is equals to 0. And the value of x lies between minus pi by 2 to plus pi by 2. Now the continuity at x is equals to 0. Only at x is equals to 0, 1 minus cos x is equals to 0. F of 0 is 68 upon 15, which is a given. Now evaluate this limit. Limit x tends to 0. F of x is equals to limit x tends to 0, cos of 4x minus cos of 9x upon 1 minus cos x. Now apply the formula cos c minus cos of t. Minus 2 times sin of c plus t upon 2 sin of c minus d upon 2 upon 1 minus cos x into 1 plus cos x multiplied n and d by 1 plus cos x. Therefore, you will get minus 2 sin of 13x upon 2 and sin of minus 5x upon 2. 1 minus cos x into 1 plus cos x. Then you will get 1 minus cos square x, which is the sin square x. Therefore, divide n and d by x square. 2 sin of 13x upon 2 into sin of 5x upon 2 upon sin square x into 1 plus cos x. Divide n and d by x square. Therefore, limit x tends to 0. 2 sin of 13x upon 2 upon 13x upon 2. Sin of 5x upon 2 upon 5x upon 2. 13 up. That is a 2 into 1 into 13 by 2 into 5 by 2 upon 1 into 1 plus 1. That is equals to 65. Therefore, the limit x tends to 0, f of x is equals to 65. But the f of 0 is equals to 68.15, and therefore, the given function is a discontinuous at x is equals to 0. Hence, f is continuous on minus pi by 2 to plus pi by 2 except at x is equal to 0 where it is a discontinuous. So this is f of x is equals to cos of 4x minus cos of 9x upon 1 minus cos x for x is not equals to 0. F of 0 is equals to 68 upon 15 at x is equals to 0. And the values of x is minus pi by 2 to plus pi by 2. Now the continuity at x is equals to 0. Only at x is equals to 0. 1 minus cos x is equals to, that will be become 0. F of 0 is 68 upon 15 which is given. Now apply the formula for cos c minus cos d upon 1 minus cos s. That is a minus 2 times sin of c plus d upon 2 sin of c minus d upon 2. Rationalized by using multiplied by 1 plus cos x to the numerator denominator. Apply the formula. Now next is the adjustment, divide n and d by x square. That is limit x tends to 0 to sin of 13x upon 2 upon 13x upon 2. Sin of 5x upon 2 upon 5x upon 2 into 13 by 2 into 5 by 2 upon sin square x upon x square into 1 plus cos x. The value of this limit is 2 into 1 into 1 into 13 by 2 into 5 by 2 upon 1 into in bracket 1 plus 1. And that is equals to 65 upon 2 which is equals to 65. This is the limit, but we have the f of 0 is a 68 upon 15. Both are not equal and hence the given function is a discontinuous at x is equals to 0. Hence f is a continuous on minus pi by 2 to plus pi by 2 except at x is equals to 0 where it is a discontinuous. Now next is f of x is equals to sin square pi x upon 3 in bracket 1 minus x bracket square and pi square sin square pi x upon 2 upon 3 plus 4 cos square pi x upon 2 for x is equals to 1 at x is equals to 2. Check the continuity at x is equals to 1. Now see this function f of x, f of 1, replace x by 1. Then you will get x is 1, sin of pi by 2, sin pi by 2 is 1, pi into 1 square is pi. That is a 3 plus, what is it again here, x is equals to 1, cos of pi by 2, cos 90 is 0. Therefore overall you will get 3 here. Now see this again. Pi into 1 square upon 3 plus 4 into 0. Therefore f of 1 is equals to pi by 3 which is equals to pi square upon 3. That is the pi into pi. Pi square upon 3. This is the value of f of 1. Limit x tends to 1. F of x tends to 1. Sin square pi x upon 3 in bracket 1 minus x square. Put as limit x tends to 1. Therefore here we will take the substitution. X is equals to 1 plus h. As x tends to 1, h tends to 0. Therefore, you will get again limit h tends to 0 sin of sin square pi in bracket 1 plus h upon 3 in bracket minus h in bracket square. Now see this here, pi into 1, pi into h, sin square pi plus pi h. Now sin of pi plus theta, the given function remains as it is. It goes in third quadrant. It will become minus sin of pi h into minus sin of pi h, and overall it will become sin square pi h. Three h square. Now the adjustments are These are the formulas. Sin square pi h upon pi square h square into pi upon 3. The value of this limit is 1. 1 into pi square upon 3. This is the number 2. Therefore, from 1 and 2, limit x tends to 1 f of x is equals to f of 1. F is a continuous at x is equals to 1. Now next, let's see this here. Fourth one, f of x is equals to sin square pi x upon 3 in bracket 1 minus x bracket square for x is not equals to 1. Pi square into sin square pi x upon 2 upon 3 plus 4 cos square pi x upon 2 at x is equals to 1. Means that we have not given the value. We have given this trigonometric function, trigonometric expression. For that we will find out the value of f of 1 and then we will take the limit for this function. Then evaluate it. They are equal or not equal. Now see this again. F of x is equals to pi square sin square pi x upon 2. This is 3 plus 4 cos square pi x upon 2. At x is equals to 1. Okay. Replace x by 1. Then you will get pi square sin square pi upon 2. What about the denominator? Then 3 plus 4 cos square pi upon 2. Now here is the cos of pi by 2. That is a cos 90. Cos 90 is 0. 0 into 4. That is a 0. Pi square upon 3. This is the first. What is this? This is the value of the function. Now we will take the limit of the function. For this, we take this function. That is a sin square pi x upon 3 in bracket 1 minus x bracket square. To evaluate this limit, very interesting limit. As limit x tends to 1, put x is equals to 1 plus h. As x tends to 1, h tends to 0. Limit x tends to 1, f of x is equals to limit x tends to 0. Sin square pi in bracket 1 plus h. Now what is the value of 1 minus x? The value of 1 minus x is a minus h and minus h bracket square. Limit x tends to 1, f of x is equals to limit x tends to 1 sin square pi x upon 3 in bracket 1 minus x. Put x is equals to 1 plus h. As x tends to 1, h tends to 0. Limit x tends to 1, f of x is equals to limit h tends to 0. Sin square pi in bracket 1 plus h upon 3 minus h square. Multiply this pi with 1 and h. Then you will get sin square pi plus pi h. Now again, sin of pi plus theta is a minus sin theta and sin square pi plus theta, that is a minus sin theta into minus sin, that will become sin square theta. I forget to write here square. Therefore, limit x tends to 0, sin square pi h upon 3h square. Sin square pi h upon pi square h square into pi square upon 3. The value of this limit is 1. 1 into pi square upon 3. Therefore, limit x tends to 1, f of x is equals to pi square upon 3. Therefore, from 1 and 2, limit x tends to 1, f of x is equals to f of 1. And therefore, f is a continuous at x is equals to 1. Now, let's see the next. F of x is equals to mod of x plus 1 upon x square plus x minus 1. For x is not equals to minus 1 and equals to 0. For x is equals to minus 1 and x is equals to minus 1. If x is greater than minus 1, then x plus 1 is greater than 0. Mod of x plus 1 is equals to x plus 1. And if x is less than minus 1, then x plus 1 is less than 0. And how it is solved? Add 1 on both sides, then you will get x plus 1 is a positive. Therefore, mod of x plus 1 is equals to x plus 1 for x is greater than minus 1. And if x is less than minus 1, to solve this, add 1 on to this inequality. Then you will get x plus 1 is less than 0. Therefore, mod of x plus 1 is equals to x plus 1 for x is greater than minus 1 and equals to minus for x is less than minus 1. Therefore, here f of x is equals to x plus 1 upon x, 2x square plus x minus 1 for x is a greater than minus 1. For x is a less than minus 1, then it has a minus sign, and equals to 0 for x is equals to minus 1. F of minus 1 is equals to 0. This is the one. Limit extends to 1 plus right hand side limit minus extends to minus 1. That is the right hand side limit. We take the function x plus 1 upon 2x square plus x minus 1 and take the limit. Therefore, x plus 1 get cancelled. Then limit extends to minus 1, 2x minus. Replace x by 1, then you will get minus 1 upon 3. From 1 and 2, right hand side limit is not equals to the value of the function. Therefore, it is a discontinuity at x is equals to minus 1. I will see this here again. F of x is equals to mod of x plus 1 upon x to x square plus x minus 1 for x is not equals to minus 1. For x is equals to minus 1 at x is equals to minus 1. Again for x greater than minus 1, x plus 1 is a greater than 0. And mod of x plus 1 is equals to x plus 1. If x is less than minus 1, then we have a mod of x plus 1 is equals to minus in bracket x plus 1. Therefore, f of x is equals to x plus 1 upon 2x square plus x minus 1 for x is a greater than minus 1, for x is less than minus 1 and equals to 0 for x is equals to minus 1. Now here f of minus 1 is 0. Now we'll take, it's a simple that if we take the left hand side limit and the right hand side limit, again we will get here the answer of this question. As limit extends to minus 1, that is the right hand side limit. For that, we take the function, that is f of x is equals to x plus 1 upon 2x square plus x minus 1. For that is x is greater than minus 1. For the right hand side, we take this function. See this again here. Factorize it, 2x square plus x minus 1, x plus 1 in first bracket, 2x minus 1 in the second bracket, x plus 1 get cancelled, x is replaced by x by minus 1. That is equals to 1 upon minus 1 minus 2, that is minus 1 upon 3. Now these are not equal. F here is at x is equals to minus 1, it is a 0. They are not equal and the given function is a discontinuous at x is equals to minus 1. Now next problem. F of x is equals to greatest integer function, that is a x plus 1 for x belongs to minus 2, closed interval and open interval, that is open bracket, that is 2. 2 is not included there. This is the greatest integer function. Here the f of x is equals to, and it is written as like this. See this here. F of x is equals to x plus 1. F of x is equals to x plus 1 for x belongs to the closed interval minus 2 and open interval 2. F of x is equals to minus 1. For x belongs to minus 2 and open minus 1. That is here. First is a minus 1. Now next, x belongs to minus 1 and 0. If we substitute here x is equals to minus 2, then you will get minus 1. If we substitute x is equals to minus 1, x plus 1, that will become 0. X is equals to 0, then you will get 0 plus 1. It is 1 here. X belongs to 1, closed interval 1, 2. If we substitute x is equals to 1, 1 plus 1, you will get the 2. Now you have to make this type of the intervals. You define the function for the greatest integer function f of x is equals to minus 1. x belongs to closed interval -2 to 1. If we substitute x is equals to -2, then you will get -1, 0, 1, 2, like this. Now see this next here. We'll take the left hand side limit and right hand side limit. Consider the continuity at x is equals to -1. Limit x tends to -1. F of x, that is a -1. Left hand side, right hand side, both are not equal. Then therefore the given function is not continuous at -1. That is, limit does not exist. Therefore f is a discontinuous at x is equals to -1. Similarly, we can show that it is a discontinuous at x is equals to 0, 1, and hence the f is a discontinuous at x is equals to 0, x is equals to -1, 0, 1. Now see this again here. F of x is equals to greatest integer function x plus 1, x belongs to closed interval -2 open to, it's a greatest integer function f of x. This is a function that f of x is equals to -1. How this -1 comes? That is, put x is equals to -2 here, then -2 plus 1, it's a -1. For the next, what's the next? -1 to 0, 0 to 1, 1 to 2. We can take them intervals like this. Is equals to 0 for x closed interval, that is a close, -1, that is 1 is included there. Therefore here you will get the value 0. Put x is equals to 0 here, then you will get 1. Put x is equals to 1, you will get the 2. Now we check the continuity at x is equals to -1. And to check the continuity, that is the limit, we take the left hand side limit, which is that is equals to -1, the right hand side limit, that is equals to 0. Both are not equal. This is the -1, left, right, both are not equal. The given function is a discontinuous. Limit does not exist. Similarly, we can prove that it is a discontinuous at x is equals to 0 and hence f is a discontinuous at x is equals to -1, 0, and 1. We'll see the next. F of x is equals to 2x square plus x plus 1 for mod of x minus 3 is greater than or equal to 2. F of x is equals to 2x square plus x plus 1 for mod of x minus 3 greater than or equal to 2 is equals to x square plus 3 for the value of x lies between 1 to 5. Mod of x minus 3 is equals to plus or minus in bracket x minus 3. X minus 2 is greater than or equal to 2, and if we change its sign, minus in bracket x minus 3 is greater than or equal to 2. And now solve this, add 3 on both sides and again solve this. That is subtract 3 on both sides, minus x is greater than -1. It means the sign will reflect if we change it. That is, x is less than or equal to 1. Therefore x is greater than or equal to 5. F of x is f of x can be expressed as now. Now see this here, 2x square plus x plus 1 for x is less than 1. X square plus 3 for x lies between 1 to 5, and 2x square plus x plus 1 for x is greater than 5. Now check the continuity at x is equals to 1, x is equals to 5. Also the given function is what type of this is? The polynomial function. It is a continuous, and we'll check the continuity at the point where the function breaks. F of x is a polynomial function, is a continuous for x less than 1, lies between 1 to 5 and greater than 5. Now continuity at x is equals to 1, f of x is equals to 2x square plus x plus 1 for x is less than or equal to 1. Limit, left hand side limit we will take here, x tends to 2x square plus x plus 1, as the value is 4. Next is for right hand side, take the function x square plus 3, that is 4. Both are equal. The given function is a continuous at x is equals to 1. Now continuity at x is equals to 5. It's a 28. Therefore, that is equals to 56. Both are not equal, therefore the given function is a discontinuous at x is equals to 5. And overall, if you see this, the given function is a continuous except at x is equals to 5 on its domain capital R except at x is equals to 5, where it is a discontinuous. Now we will see this here. F of x is equals to 2x square plus x plus 1 mod of x minus 3 greater than or equal to 2 is equals to x square plus 3 for x lies between 1 to 5. Okay. That is mod of x minus 3 is equals to plus or minus in bracket x minus 3. And now see this here. Mod of x minus 3 is a greater than or equal to 2. It's like this, x minus 3 greater than or equal to 2. Minus in bracket x minus 3 greater than or equal to 2. Solve this. Add 3 on both sides. X is greater than or equal to 5. Minus x plus 3 greater than or equal to 2. If you solve this, then you will get x is greater than or equal to 5 and x is less than or equal to 1. F can be expressed as f of x is equals to, that is first is 2x square plus x plus 1, x is less than or equal to 1, is equals to x square plus 3 for x lies between 1 to 5, and for the last, f of x is equals to 2x square plus x plus 1 for x is greater than or equal to 5. F of x is a polynomial function. It is a continuous for x is less than 1. X lies between 1 to 5. X is greater than 5. Now continuity at x is equals to 1. F of x. We take the left hand side limit, right hand side limit. Therefore, the value of left hand side limit is 4 and right hand side limit is also 4. Therefore, it is a continuous at x is equals to 4. Continuity at x is equals to 5. That is equals to 28 left hand side. Right hand side limit is 56. Both are not equal. The given function at that point. Therefore, the given function is a discontinuous at x is equals to 5. Therefore, f is a continuous on its a domain capital R except at x is equals to 5, where it is a discontinuous. All these are the descriptive type questions. Now, next is third one. Identify the discontinuities, if any, for the following functions as either a jump or removable discontinuity. on their respective domains. First is f of x is equals to x square plus x minus 3 for x belongs to closed interval minus 5 open minus 2, x square minus 5 for the open minus 2 for close 5. F is a continuous in minus 5 open 2 and the minus 2 close 5 since it is a polynomial function. Now we'll check its continuity where the function breaks. The given function break at x is equals to minus 2 and we take the left hand side limit, right hand side limit, limit x tends to left hand side limit. For that we take the function x square plus x minus 3 minus 2 square plus minus 2 minus 3, then you will get minus 1. Limit x tends to minus 2, which is minus 1. F of x is equals to x square plus 5, which is minus 2 square. That is minus 2 square minus 5. That is minus 1. And in this case, f of minus 2 is not defined. F is a discontinuous at x is equals to minus 2. This discontinuity is removable and can be removed by redefining the function as follows. F of x is equals to x square plus x minus 3 for x belongs to closed interval minus 2 open minus 2 closed interval. X belongs to minus 5 which is the closed and minus 2 which is open. F of x is equals to x square minus 5 where x belongs to open minus 2 and close 5 and equals to minus 1 for x is equals to minus 2. Now let me see this again here. Identify the discontinuity if any for the following functions as either a jump or the removable discontinuity on their respective domains. F of x is equals to x square plus x minus 3. X belongs to closed interval, that is minus 5 open minus 2. F of x is equals to x square minus 5 for x belongs to open minus 2 and closed 5. The given function breaks at x is equals to minus 2. Again, it is a polynomial function, it is a continuous, and we check the continuity at x is equals to minus 2. And if we see this continuity and left hand side limit is minus 1 and the right hand side limit is also minus 1. F of minus 2 is not defined here. Therefore, here we will define the f of minus 2 and the problem is over. F of minus 2 is not defined here. Therefore, discontinuity is removable and can be removed by redefining the function as follows. F of x is equals to x square plus x minus 3 for x close 5 open minus 2 is equals to x square minus 5 for x belongs to open minus 2 close 5 and equals to minus 1 for x is equals to minus 2. Next problem. F of x is equals to x square plus 5x plus 1 for x lies between 0 to 3. F of x is equals to x square plus x plus 5 for x lies between 3 to 6 greater than 3 and here equals to 6. For x lies between 0 to 3, f of x is equals to x square plus 5x plus 1 being a polynomial function and is continuous. For x lies between 3 to 6, again x cube plus x plus 5 being polynomial function is a continuous. Now the continuity at x is equals to 3 where the function breaks. Limit x tends to 3, that is the left hand side limit. Limit x tends to 3, x square plus 5x plus 1, and its value is 25. Now the right hand side limit, it is 35. Both are not equal. Left hand side limit is not equals to the right hand side limit. Therefore, the f of x does not exist. F is a discontinuous at x is equals to 3. F is a continuous on closed interval 0 to 6 except at x is equals to 3, where it has a jump discontinuity. Now the next thing, you can see this here. F of x, the function 0 to 3, 3 to 6. It's a polynomial function, continuous. Function breaks here at x is equals to 3. Left limit, right limit. Take the limit. It's a 25. Replace x by 3. Take the limit. Take the function x square, x cube plus x plus 5. I forget to write here. Here is x cube. Next is x cube plus x plus 5. It's a 35. Both are not equal. Limit does not exist. Therefore, f is a discontinuous at x is equals to 3. F is a continuous on closed interval 0 to 6 except at x is equals to 3. It has a jump discontinuity. Okay. Now let's see this next one. F of x is equals to x square plus x plus 1 upon x plus 1 for x belongs to closed interval 0 and open 3. 3x plus 4 upon x square minus 5 for x belongs to 3 to 6. For x belongs to closed 0 to 3, f of x is equals to x square plus x plus 1 upon x plus 1, being a rational function, is a continuous except it's a denominator x plus 1 is equals to 0, that is x is equals to the given function is a discontinuous except at x is equals to minus 1, where it does not belong to that interval 0 to 3. Therefore, f is a continuous on the interval 0 to 3. For x belongs to the interval 3 to 6, f of x is equals to 3x plus 4 upon x square minus 5. Being a rational, is a continuous at except at its a denominator x square minus 5 is equals to 0. That is x is equals to plus or minus root 5. But root of 5 does not belong to that interval. Therefore, f is a continuous on 0 to 6 except possibly at x is equals to 3. I will check the continuity at x is equals to 3. It's a left hand side limit, x square plus x upon x plus 1, 9 plus 3 plus 1 upon 3 plus 1, that is 13 by 4. Also, f of x is equals to 3x plus 4 upon x square minus 5 for x belongs to closed interval 3 to 6. Right hand side limit, f of 3, its value is 13 by 4. Therefore, f of 3 is equals to limit x tends to all values are equal, and hence it is a continuous at x is equals to 3. Hence, f is a continuous on its domain 0 to 6. Now we'll see this again. The function is f of x is equals to x square plus x plus 1 upon x plus 1 for x belongs to the interval 0 to 3 is equals to 3x plus 4 upon x square minus 5 for x belongs to closed interval 3 to 6. The given function breaks at the point 3. Now as x belongs to 0 to 3, being the polynomial function, it is a continuous except at x is equals to minus 1, where that is minus 1 does not belongs to 0 to 3. Therefore, it is a continuous on 0 to 3. Again, x belongs to 3 to 6. This is the function. It is a rational function, continuous. And it will be discontinuous if x square minus 5 is equals to 0. That is, x is equals to plus or minus root of 5, where root of 5 does not belong to 3 to 6. Therefore, f is a continuous on 0 to 6 except at possibly at x is equals to 3. Continuity at x is equals to 3. Therefore, we will check the continuity at x is equals to 3. And therefore, we take the left hand side limit and right hand side limit. X square plus x plus 1 upon x plus 1, which is 13 by 4. Its value is also 13 by 4. And therefore, it is a given function is a continuous on its domain 0 to 6. Now we take the next is fourth one. Discuss the continuity of the following function at the point or on the interval indicated against them. Identify the type of the discontinuity and state whether the discontinuity is removable if it has a removable discontinuity. Redefine the function so that it becomes continuous. F of x is equals to x plus 3, x square minus 6x plus 8, x square minus x minus 12. Now here domain will take the set of real number. F of x is equals to x plus 3 in bracket x square minus 6x plus 8 upon x square minus x minus 12. In first bracket x plus 2, second bracket x minus 4 into x minus 2. The factors are x square minus x minus 12 upon x minus 4 into x plus 3. Here x minus 4 get cancelled. This is the rational function. It is a continuous except at where its denominator is 0. Now the denominator will be 0 at x is equals to 4 and x is equals to minus 3. Therefore, the limit extends to 4. X minus 4 get cancelled. Limit is 2. F has removable discontinuity at x is equals to 4. Also, at x is equals to minus 3, which is the minus 5. F has a removable discontinuity at x is equals to minus 3. Hence, f is a continuous on its domain capital R, except at x is equals to 4 and at x is equals to minus 3, where it has a removable discontinuity. Therefore, we will redefine the function as follows. F of x is equals to x plus 3 in bracket x square minus 6x plus 8 upon x square minus x minus 12. For x is not equals to 4 and x is not equals to minus 3 equals to minus 5 for x is equals to minus 3 and equals to 2 for x is equals to 4. Now we'll see the next one. F of x is equals to, f is defined on the set of real numbers, their factors. The given function is discontinuous only where the denominator is a 0, because the function will be not defined, at which point x is equals to 4 and x is equals to minus 3, and for that we will redefine the function. Now see this here, as limit x tends to 4, x minus 4 get cancelled, you will get the value 2. F has a removable discontinuity at x is equals to 4 and also x tends to minus 3, where it becomes 0. Then we have the value minus 5, limit of the given function is minus 5. F has a removable discontinuity at x is equals to minus 3, hence f is a continuous except all the points of its domain capital R except at x is equals to 4 and at x is equals to minus 3, where it has a removable discontinuity. We redefine the function as follows. That is f of x is equals to x plus 3 x square minus 6x plus 8 upon x square minus x minus 12 for x is not equals to 4, x is not equals to minus 5 for x is equals to minus 3 and equals to 2 for x is equals to 4. Therefore, we redefine the function. Now see this again here. Next, f of x is equals to x square plus 2x plus 5 for x is greater than or equal to 3, x cube minus 2x square minus 5 for x is greater than 3. Here is x is less than or equal to 3, x is greater than 3. I will take the left hand side limit, right hand side limit. Given function is a polynomial function, it is a continuous. We'll check its a continuity at x is equals to 3. Left hand side, that's the first, that is the right hand side limit is 4, left hand side limit is 20. Therefore, the given function is both are not equal. The given function is a discontinuous. Limit does not exist. Therefore, it is a discontinuity at x is equals to 3. Therefore, the given function is a continuous on the capital R except at x is equals to 3. Where it is a discontinuous, which is irremovable. Now you can see this here also. F of x less than or equal to 3, greater than 3. Right hand side limit x cube minus 2x square minus 5, it's a 4. Left hand side limit, that is a 20, replace only x by 3. Both are not equal, therefore limit does not exist. F is not continuous at x is equals to 3. Otherwise, the given function is a continuous on capital R except at x is equals to 3, where it is a discontinuous, which is irremovable. Now we'll see the next one. Find k if the following function are continuous at the points indicated against them. F of x is equals to 5x minus 8 upon 8 minus 3x and bracket raised to 3 upon 2x minus 4 and equals to k for x is equals to 2. Check the continuity at x is equals to 2. F is given to be continuous at x is equals to 2. By the definition, the value of the function is equals to the limit of the function. F of 2 is equals to k. Now we'll find out the limit as x tends to 2. F of x, limit x tends to 2. 5x minus 8 upon 8 minus 3x up bracket is to 3 upon 2x minus 4. Now here we'll take the substitution as limit x tends to 2. X is equals to 2 plus t. As x tends to 2, x tends to t tends to 0. Therefore, limit x tends to 2, f of x is equals to limit t tends to 0. Replace x by 2 plus t and evaluate it. Therefore, limit t tends to 0. You can take also h there. That is a 5 plus 2 plus 5t upon 2 minus 3t and whole bracket is to 3 upon 2t. Limit t tends to 0. Divide n and d by 2. That is 1 plus 5t upon 2. 1 minus 3t upon 2. Whole bracket raised to 3 upon 2t. Limit t tends to 0. 1 plus 5t upon 2 bracket raised to 3 upon 2t. Limit t tends to 0. 1 minus 3t upon 2 bracket raised to 3 upon 2t. Now this is the limit of the form 1 plus x bracket raised to 1 upon x or 1 plus 1 upon x bracket raised to x. Adjust here their coefficients. Here is a minus 9 by 4. It's a very and overall the answer is e raised to 24 upon 4 and that is e raised to 6. Therefore from 1 to and the 3 k is equals to e raised to 6. Again see this again here one by one step by step. Here is a k at x is equals to 2. Continuous f of 2 is equals to k. We will find out the limit. For that, put x is equals to 2 plus t. As x tends to 2, t tends to 0. Limit x tends to 2, f of x is equals to limit t tends to 0. X is replaced by 2 plus t minus 8 upon 8 minus 3 in bracket 2 plus t. 3 upon 2 in bracket t plus 2 minus 4. That is a 3 upon 2t plus 4 minus 4 get cancelled. Divide n and d by 2. That is the limit t tends to 0. 1 plus 5t upon 2 upon 1 minus 3t upon 2. Bracket raised to 3 upon 2t. Now separate it. Limit t tends to 0. 1 plus 5t upon 2. Bracket raised to 3 upon 2t. Limit t tends to 0. 1 minus 3t upon 2. Bracket raised to 3 upon 2t. And here adjustment. That is the limit t tends to 0. 1 plus 5t upon 2. Bracket raised to 2 upon 5t and bracket complete 15 upon 4. Limit t tends to 0. 1 minus 3t upon 2. Bracket is to minus 2 upon 3t and bracket is to 9 by 4. That's the value is 15 by 4. E raised to 15 by 4 and e raised to minus 9 by 4. If you add this, then you will get e raised to 24 upon 4 and that is e raised to 6. Therefore, from 1 to 3, k is equals to e raised to 6 because the function was continuous and therefore 2 is equals to e raised to 6. Now the next is Next problem, f of x is equals to 45 raised to x minus 9 raised to x minus 5 raised to x plus 1 upon k raised to x minus 1 into 3 raised to x minus 1 for x is not equals to 0 equals to 2 by 3 for x is equals to 0. Now given function is a continuous, it's very simple limit. F is a continuous. The value is equals to the limit of the function. Limit x tends to 0 f of x 45 raised to x minus 9 raised to x 5 raised to x plus 1 upon k raised to x minus 1 into 3 raised to x minus 1. Limit x tends to 0. 9 into 5 bracket raised to x minus 4 9 raised to x minus 5 raised to x plus 1. Separate it. 9 raised to x 5 raised to x minus 9 raised to x minus 5 raised to x plus 1. Take 9 raised to x as a common. Then you will get 5 raised to x minus 1 minus 1. Therefore 3 raised to x minus 1. Separate it. Limit x tends to 0. 5 raised to x minus 1. 9 raised to x minus 1. K raised to x minus 1. 3 raised to x minus 1. Divide n and d by x square. 5 raised to x minus upon x into 9 raised to x minus 1 upon x. K raised to x minus 1 upon x. 3 raised to x minus 1 upon x. Log of 5 into log of 9 into log of k. Log of 3. Log of 5. Log of 9 means what? 3 square. Log of k. Log of. Therefore you will get that is a 2 times log of 5 upon log of k. Now what is the value of the function? It's a given. Therefore from 1 and 2, 2 log of 5 upon log of k is equals to 2 by 3. 2 get cancelled. Therefore 3 log of 5 is equals to log of k. That is a log of 5 raised to 3 is equals to log of k. That is a k is equals to 5 raised to 3, which is equals to 125. Now we'll see this again. See this. The given function, its value is a 2 by 3. F of 0 is a 2 by 3. F is a continuous at x is equals to 3. 45 means what? 9 into 5 bracket raised to x minus 9 raised to x minus 5 raised to x plus 1. Separate it. 9 raised to x into 5 raised to x. Take 9 raised to x as a common. From the remaining 2, that is a minus 5 raised to x plus 1. Take the minus 1 as a common. Therefore 5 raised to x minus 1 into 9 raised to x minus 1 upon k raised to x minus 1 into 3 raised to x minus 1 divide n and d by x square. Therefore 5 raised to x minus 1 upon x into 9 raised to x minus 1 upon x, k raised to x minus 1 upon x into 3 raised to x minus 1 upon x. The first is log of 5, log of 9, log of k, log of 3. Log of 9 means what? 3 raised to 2. Log of k, log of 3. Therefore log of 3 get cancelled. Therefore you will get limit x tends to 0 f of x is equals to 2 into log of 5 upon log of k. Therefore from 1 and 2, that's a 2 times log of 5 upon a log of k, that is equals to 2 upon 3, 2 get cancelled. Cross multiplication, 3 times log of 5 is equals to log of k, and that is it. 5 raised to 3 is equals to log of k, and that is equals to log get cancelled. Take antilog on both sides. Therefore k is equals to 5 raised to 3. K is equals to 125. Now the next is find a and b if the following functions are continuous. Indicated in the interval f of x is equals to 4 tan x plus 5 sin x upon a raised to x minus 1 for x is less than 0 is equals to 9 upon log of 2 for x is equals to 0 is equals to 11x plus 7x cos x upon b raised to x minus 1 for x is greater than 0. Now here f of 0 is 9 upon log of 2. We'll check it's a continuity for left hand side, right hand side. For the left hand side, we take the function f of x is equals to 4 tan x plus 5 sin x upon a raised to x minus 1 divide n and d by x. Therefore 4 tan x plus 5 sin x upon x a raised to x minus 1 upon x. Limit x tends to 0, 4 tan of x upon x plus 4 sin of x upon x a raised to x minus 1 upon x. The value of this limit tan of x upon x is 1, 1 into 4, 5 into 1 log of a, that is a 9 upon log of a. This is the first one. Limit x tends to 0, that is the right hand side, limit x tends to 0, 11x plus 7x cos x upon b raised to x minus 1 divided n and d by x. Then you will get 11 plus 7 into 1 upon log of b. That is 11 plus 7 is 18 upon log of b. This is number 3. Given function is a continuous. Then we will equate it. That is the left hand side limit is equals to right hand side limit is equals to the value of the function. 9 log of a, 18 upon log of b, 9 upon log of 2, 9 upon log of a is equals to 9 upon log of 2, that is a is equals to 2. 18 upon log of b is equals to, that simplify 2 times log of b, that is 1 upon log of 2 cross multiplied, that is a log of b is equals to 2 raised to 2 log of, therefore b is equals to 4, and hence a is equals to 2 and b is equals to 4. Now see this again. Here is the function. For x is less than 0, x is equals to 0, x is greater than 0, left hand side, right hand side, value of the function. Now first limit, that is a limit, a very simple limit is here. 4 tan x plus 5 sin x upon a raised to x minus 1 divided n d by x. Then you will get limit x tends to 0, 4 tan of x upon x plus 5 sin of x upon x a raised to x minus 1 upon x. The limit of tan of x upon x as x tends to 0 is 1, that is a 4 into 1, plus sin of x upon x as x tends to 0 is 1, 5 into 1, and the denominator is a raised to x minus 1 upon x as x tends to 0 log of a, that is a 9 upon log of a, that is a 9 upon log of a. This is the first. Right hand side limit, that is 11x plus 7x cos x upon b raised to x minus 1 divided n and d by x, 11 plus 7 into 1 log of b, that is a 18 upon log of b. Given function is a continuous. Left, right and value of the 0, value of the function at x is equals to 0, both are equal. Equate it, 9 upon log of a, 18 upon log of b is equals to 9 upon log of 2. 9 upon log of a is equals to 9 upon log of 2. This 9 get cancelled, then you will get log of 2 is equals to log of a, therefore a is equals to 2. And for this, that is a 9 upon log of a. Now see this one by one. 9 upon log of a is equals to 9 upon log of 2. It indicates that the a is nothing but the 2. For the next, 18 upon log of b is equals to 9 upon log of 2. 18 upon log of b is equals to 9 upon log of 2. That is a 2 upon log of b is equals to 1 upon 2. And simplify it, then you will get the cross multiplication. Log of b is equals to 2 times log of 2. That is a log of b is equals to log of 2 raised to 2. That is equals to log of 4. And therefore b is equals to 4. And hence a is equals to 2 and b is equals to 4. Now let's see the next example. Second one. F of x is equals to x square plus bx plus 1 for mod of x minus 2 is greater than or equal to 2 and is equals to 3x plus 2 for x lies between 1 upon 2 and 5 by 2. Now again, mod of x minus 2 is equals to plus or minus 2x minus 3. For the first, 2x minus 3 is greater than or equal to 2. And for the second, minus in bracket 2x minus 3 is greater than or equal to 2, which is nothing but the 3 minus 2x. I am operating the minus sign here. Therefore, 2x add plus 3 on both sides, then you will get 2x is greater than or equal to 5. And here 3 minus 2x is greater than 2. Again here, we simplify here, add 2x on both sides. If we add 2x on both sides, then what will happen? That is a 3 minus 2x plus 2x get cancelled. And on the right hand side, 2 plus 2x. Then minus 2 on both sides. Then you will get, that is a 1 is a greater than 2x. Therefore here, x is a greater than or equal to 5 by 2 and x is less than or equal to 1 upon 2. F can be expressed as f of x is equals to ax square plus bx plus 1 for x is a less than or equal to 1 and equals to 3x plus 2 for x is lies between 1 and 5 by 2 and equals to ax square plus bx plus 1 for x is a greater than or equal to 5 by 2. Therefore, the given function breaks at the point 1 upon 2 and the 5 by 2. We'll check the its continuity. Therefore, f is a continuous on its domain at x is equals to 1 upon 2. Check it. Since f is a continuous at x is equals to 1 upon 2, f of 1 upon 2, it's a right hand side limit first. The function 3x plus 2, replace x by 2, 3 by 2 plus 2. That is a 7 by 2. F of 1 upon 2 is equals to 7 by 2. F of x is equals to x square plus bx plus 1. A into 1 upon 2 bracket square plus b into 1 upon 2 plus 1. A by 4 plus b by 4 plus 1. After simplifying, you will get a plus 2b plus 4 upon 4. That is equals to 7 by 2. If we simplify then you will get a plus 2b plus 4 is equals to 7 by 2 into 4. That is a plus 2b plus 4 is equals to 14. A plus 2b is equals to 10. At x is equals to 5 by 2. F of 5 by 2 is equals to limit x tends to 5 by 2, which is the left hand side limit. We take the function. Therefore, 19 by 2 is equals to, this is the right hand side. Both are equal. After substituting the values, that is a 25a plus 10b is equals to 34. Therefore, a plus 2b is equals to 10 and the next equation is a 25a plus 10b is equals to 34. Now simplify these two, solve these two equations. Therefore, b is equals to 216 upon 40, that is a 27 upon 5. A plus 2b is equals to 10. We substitute the value, then you will get the value of a is equals to minus 4 by 5. A is minus 4 by 5, b is a 27 upon 5. Now see this again here. The function plus sign minus sign, f can be expressed as, for x is less than or equal to 1 upon 2, x lies between 1 upon 2 and 5 by 2, x is greater than or equal to 5 by 2, f is a continuous on its domain. Check the continuity at x is equals to 1 upon 2 and x is equals to 5 by 2. At x is equals to 1 upon 2, that's the right hand side limit, and it's a value that is equals to 7 upon 2. And next is a ax square plus bx plus 1 is a 7 upon 2 is here. Therefore equate it. A plus 2b is equals to 10. At x is equals to 5 by 2. Left hand side limit 3x plus 2. Its value is a 19 by 2. 19 by 2. It's a right hand side limit. Substitute its a value. You will get the equation 25a plus 10b is equals to 34. A plus 2b is equals to 10. Solve these two equations. Multiplied by here, that is a 25. Subtract it. Minus 40b is equals to minus 216. Therefore, b is equals to 27 upon 5. A plus 2b is equals to 10. Substitute the value. b 27 upon 5. A plus 54 upon 5. And therefore, the a is a minus 4 upon 5. A is minus 4 upon 5. B is equals to 27 upon 5. These are the values. 7. Find f of a if f is a continuous at x is equals to a, where the function f of x is equals to 1 plus cos of pi x upon pi in bracket 1 minus x bracket square. That is x is equals to 1. There must be. Given function is a continuous at x is equals to 1. We want to find out the f of a. It's a value only. To find out only the limit of the function, because the given function is a continuous at x is equals to 1. It's very simple problem. Put x is equals to 1 plus h. As x tends to 1, h tends to 0. F of 1 is equals to limit h tends to 0, 1 plus cos of pi in bracket 1 plus h upon pi h square. Therefore, you will get 1 plus cos of pi plus pi h upon pi h square. And here, the cos of pi plus pi h goes in third quadrant. In third quadrant, cos is negative. And the function remains as it is because it is a pi plus theta. Therefore, 1 minus cos of pi h upon pi h square. Now, see this limit is again interesting. Now, 1 minus cos of pi h, we will again rationalize it. Multiply numerator and denominator 1 plus cos of pi h upon 1 plus cos of pi h. Then you will get 1 minus cos square pi h upon pi h square upon into 1 upon 1 plus cos of pi h. Therefore, you will get sin square pi h upon pi h square into 1 upon 1 plus. Pi is adjusted there. The value of this limit is 1 into pi upon, as h tends to 0, cos of 0 is 1. That is pi upon 2. Therefore, 1 into pi upon 2. F of 1 is pi upon 2. The value of f of 1. That is, we say that the a is equals to 1. X is equals to 1. That is. Now the next is, you see this again here. F of x is equals to 1 plus cos of pi x upon pi in bracket 1 minus x bracket square. At x is equals to a is equals to 1 means what? X is equals to 1. Continuity at x is equals to 1. Limit x tends to 1. 1 plus cos of pi x upon pi in bracket 1 minus x bracket square. Put x is equals to 1 plus h. As x tends to 1, h tends to 0. Limit f of 1 is equals to limit h tends to 0. 1 cos of pi in bracket x is replaced by 1 plus h upon pi 1 minus x is the h square. 1 plus cos of pi in bracket pi h. But what is the cos of pi plus pi h is minus cos of pi h upon pi h square. Multiplied n and d by 1 plus cos of pi h upon 1 plus cos of pi to the numerator denominator. It becomes limit h tends to 0. 1 minus cos square pi h upon pi h square into 1 upon 1 plus cos of pi h. That is a sin square pi h upon pi square h square into pi upon 1 plus cos of pi h. The value of this limit is 1 into pi upon 1 plus 1. That is pi upon 2. F of 1 is pi by 2. Now the next is f of x is equals to 1 minus cos of 7 in bracket pi x minus pi upon 5 in bracket x minus pi for x is not equals to pi and x is equals to pi. That is again the f of a limit x tends to pi 1 minus cos of 7 in bracket x minus pi upon pi in bracket x minus pi bracket square. Again the substitutions x is equals to pi plus h as x tends to pi, h tends to 0. This is the 1 minus cos of 7h upon 5h square multiplied and by 1 plus cos of 7h upon 1 plus cos of 7h. Then you will get limit h tends to 0. 1 minus cos square 7h upon 5h square into. One thing is remaining there. I forget to write 1 upon 1 plus 7h. No, I will write here. Therefore, now here see this, that is the sine square 7h upon, here we have only the 5. Here we will require 49h square, therefore multiplied and by 49 upon 5. Value of this limit is 1, 1 into 49 upon 5 up into 1 upon 1 plus 1, that is a 2. And therefore, sine square 7h upon 49 into h square. That is 49 upon 10. Therefore, the f of a is equals to 49 upon 10. Now the next is in second here. Then put x is equals to pi plus h as x tends to pi, h tends to 0. Rationalize it, multiplied 1 plus cos of 7h sine square 7h upon 5h square into 1 upon 1 plus cos of 7h sine square 7h upon 49h square into 49 upon 5 into 1 upon 1 plus cos of 7h. The value of this limit is 1 square, 49 upon 5 into 1 upon 1 plus 1, and that is 49 upon 10. Therefore, f of a is equals to 49 upon 10. Now the next is number 8. Solve using intermediate value theorem. Show that 5 raised to x minus 6x is equals to 0 has a root in 1 to 2, closed interval 1 to 2. 5 raised to x minus 6x, f of 1, find the value. That is equals to minus 1, which is less than 0. And f of 2, x is equals to 2, which is 13, which is positive. It means that the root lies between 1 and 2. Because the value is minus 1 is here, and here is a 13. In between there is a one more value, that is a value, which is 0. That is f of 1, and here is a f of 2. Therefore, f is a continuous on closed interval 1 to 2 by intermediate value theorem for continuous. There exists C belongs to closed interval 1 to 2 such that f of C is equals to 0. That is a 5 raised to x minus 6x is equals to 0 has a root between 1 and 2. Now the next is, again see this here, f of x is equals to 5 raised to x minus 6x, f of 1, find the value, f of 2, f of 1 is minus 1, less than 0, f of 2 is 13, greater than 0. Its values lies between minus 1 and 13. In between there is one more value, will be 0. f of 1 less than 0, less than f of 2. F is a continuous on closed interval 1 to 2. By intermediate value theorem for the continuous, there exists a C belongs to closed interval 1 to 2 such that f of C is 0. Therefore, the 5 raised to x minus 6x is equals to 0 has a root between 1 and 2. Now we'll again see this here. The last problem, f of x cube minus 5x square plus 3x plus 6 is equals to 0 has at least two real roots between x is equals to 1 and x is equals to 5. No problem, it has the two solutions. F of x is equals to x cube minus 5x square plus 3x plus 6, which is polynomial function. Hence continuous on closed interval 1 to 5. We factorize f of x by synthetic division. Now the coefficient 1, minus 5, 3, 6. You will say that why you have taken that 6. That is 6. The factors of 6 is plus or minus 1, plus or minus 2. I am checking by 2. 1 as it is. 1 into 2, 2. Minus 5, plus 2, minus 3. Minus 3 into 2, minus 6. Plus 3 minus 6 is minus 3. Minus 3 into 2, minus 6. That's overall, it's a 0. And therefore, f of x is equals to, what are the factors? First factor is x minus 2. Second factor, x minus 3x minus 3. That is x square minus 3x minus 3. F of 1 is equals to, if we substitute, replace x by 1. 1 minus 2. 1 square, 3 into 1, minus 3. That is a positive. And what about the f of 2? Which is the equals to 0. Therefore, x is equals to 2 is the root of the f of x is equals to 0. Now, f of 3, which is negative, and f of 4, which is positive. Again, the root lies between 3 and 4. Therefore, f is a continuous. On closed interval 3 to 4, f of 3 is negative, f of 4 is positive. By intermediate value theorem, for continuous function f of x is equals to 0 has a root between 3 and 4. And therefore, there are the two roots, x is equals to 2 and a root between x is equals to 3 and x is equals to 4. And hence f of x is equals to 0 has at least two roots between 1 and 5. Again, see this here. This is the function. Synthetic, by the synthetic division, we will have f of x is equals to, factorize it, f of 1, f of 2, it will become 0. F of 2 is the root of the function. Because the polynomial is a 0. Now next, f of 3 is a negative, f of 4 is positive. Therefore, f is a continuous on closed intervals 3 to 4. F of 3 is negative, f of 4 is positive. By intermediate value theorem, is a continuous function. F of 0 has a root between 3 and 4. There are the two roots, x is equals to 2 and a root between 2, 3 and 4. Therefore, f of x is equals to 0 at least two roots between 1 to 5. And in this way, we have completed the miscellaneous exercise for the continuity. Now we'll see in the next video. Till then, goodbye.